Hello, this is Dr. Flight, and this will be a video where we talk about the process steps in SPSS for a non-hierarchical cluster analysis. Okay, so this will set you up. You want to run these steps when you look for a non-hierarchical process. If you looked at the other videos or looked at other videos or read text that talks about the difference between non-hierarchical and hierarchical processes, this will specifically focus on non-hierarchical in this particular example. So as we set this up and the commands that you want to look at, within the analysis tab, you want to go to classify and then Kmeans Cluster. Kmeans Cluster. Okay, so identified within SPSS will be the K-means process where we want to specify the number of clusters that'll be used, but just know that there are different methods in a non-hierarchical approach, and the one that is specified specifically by SPSS is the parallel threshold approach, the parallel threshold approach. There's also a sequential threshold and an optimizing procedure. So, but those are not what's specified initially. The other thing that you'll notice that's pre-specified that is done automatically for you is that Euclidean distance is the distance measure that's used, as opposed to the others that may be available in non-hierarchical K-means. It's Euclidean distance and then a parallel threshold. So other options to check would be things like the initial cluster center, and then also an ANOVA table, and then cluster information for each case. Now, ideally, if you can identify outliers before you do this process, that would be good. There's not going to be an option for you to identify outliers in the process until you reach the output. So you may need to run the data and then look at your output and see if you can find some outliers there, but it's going to be difficult to do that. So if you can find outliers in advance, that would be good. You also want to create standardized variables or z-scores for your variables in advance as well. If your scales are all identical, then you may not need to do this. So in other words, if your scales are identical, you might not be as concerned with this. However, if not, then you definitely need to standardize your data. Okay, so outliers, standardized data, and then check the boxes. So to illustrate this and to show you what it'll look like, we have the first dialog box that is open. So this is the K-means approach here in terms of the cluster analysis. We've placed in this box the variables that we're going to use in this particular regression or this analysis, and we've specified in advance the number of clusters that we're going to use. Okay, specified that in advance. Now we're going to have some check boxes here, some additional boxes that'll open up. But initially, again, variables and number of clusters that you anticipate using. So the iterate box, you most likely will not deal with too much here, except that you may increase the number of iterations beyond 10. That may be an option that you choose to do. It will take longer, it'll take computational effort, but it's the computer working and not you. So if you increase that, it won't be bad. There will be an output box, and there'll be a little note at the bottom if non-convergence happens. So you may need to look at that output, and if convergence doesn't take place, you'll make that higher. Under save, this saves new variables. So the cluster membership and the distance from cluster center, that'll be the Euclidean distance that's measured from the center of the cluster to each observation. Cluster membership is just like any other membership. It'd be like 1, 2, 3 or whatever, depending on how many clusters you have. It groups your observations into the cluster in which it belongs. Finally, under options, we have initial cluster center, the ANOVA table, and then cluster information for each case. Now, this cluster information for each case, that may create a really big table if you have a lot of data, and so you may not choose to have this. You might not choose to have this last one here. And the initial cluster center doesn't really tell you a whole lot. It's a small little table though, but the ANOVA table is good. You certainly want to do that. And you want to deal with missing data however you feel is appropriate. Okay, so looking at some of this output data then that you're going to see after you run this non-hierarchical analysis, you're going to begin with this initial cluster center. So remember we talk about seeds and the seed location. So this alludes to the seed location, and we have different clusters. We have 3 clusters actually in this example. When we have 4 variables, and so these would be the locations, the estimated locations where we would start the analysis with, and you can specify, if you want to specify in advance what you want these seed locations to be, you can. However, SPSS will go ahead and input those for you. After a series of iterations, and in this case convergence was achieved due to no or small changes within 10 iterations. So again, if you need more iterations for convergence, this would be that message that you look for. It'll tell you it didn't converge if it didn't converge, but we have a 0 here, so we know it did. And these sizes are going to go down as convergence happens and as a solution is created. After the iteration happens, the final cluster centers are revealed. And this is reported, and this is the relative place or center of each of these 4 variables within each of these 3 clusters. So this is like the average, it's like the average score on these 4 variables of the members of each cluster. So you can see here Salesforce image. Cluster 1 is very high, whereas clusters 2 and 3 are basically even. Cluster 2 is very high on technical support. Cluster 1 is in the middle, and cluster 3 is very low. Warranty and claims seems to be low for number 3, but about the same for 1 and 2. And then for complaint resolution seems to be the highest with cluster 1, middle for cluster 2, and the lowest for cluster 3. So even here we can see that there are 3 distinct clusters, and they vary considerably on these different elements here. So that's good, and this actually is confirmed with our ANOVA table. So what we're doing is we're looking by variable, and the ANOVA table, which will give us this F, says that there is significant difference between the 3 clusters on all 4 of our variables, because they're all four different. So like if you were to look at the difference between 6.4 and 4.8, that would be significant. The distance between 6.6 and 3.6 on tech support, that would be significantly different, and so on. The last box that you look at here in the Kmeans, which is important to us, would be cluster membership. It would appear we had 200, it looks like we have 200 total respondents 55 are in cluster 1, 76 are in cluster 2, and then 69 in our cluster 3. You know, those it's not going to be evenly distributed, but there's no cluster that has a really small group. These are all fairly well populated clusters, so we would say that these make some pretty good sense moving forward. Okay, so this would be the first grouping to look at. If we looked a little closer at the final cluster center box, so this output table, you can actually double click on this, and when you double click on this box, you can produce tables which show and illustrate graphically the difference between our clusters and the different variables that are here. So graphically then, we can see cluster 1 is very high in the Salesforce image, whereas in cluster 2 and 3 they're lower and about even. We can see that tech support is highest for cluster 3, and so on and so forth. So this is an evaluative tool that you can use again to help illustrate the differences in clusters and how individual variables impact the different clusters that are available to us. As I mentioned, we looked at the F statistic and the ANOVA table, so we've already looked at these. And again, it tells us that there is significant differences between the three clusters on each of these four variables. So each of these variables helps differentiate the clusters from each other, and we also have a very even, not a very even, but an even enough distribution of our observations between the three groups. So that's something that's helpful. That's good to know. The very last thing that we'll look at, which is sort of an added-on type of an approach, you can do this in other ways using other ANOVA tables. But in SPSS, we're allowed to check this cluster membership box and the distance between clusters with the save. So this group assignment actually, and in this case it's this variable that's right here, this actually creates that new variable which places the groups, the observations into groups, which we can then do further ANOVA work and profiling work and so far in. So now we can actually statistically compare cluster 1 to 2 to 3, and you'll see there's a 1 here, and there's a 2 here, another 2, a 3, and so on and so forth. So this then gives us the actual clustering variable to do additional research with. Okay, so this was just a rundown on the input strategy that you'll use for doing a non-hierarchical cluster analysis. It's actually very straightforward and pretty fun to run. Again, what you're going to want to do is use the data to run a non-hierarchical cluster. Then you'll probably run a hierarchical cluster, and you may even want to do a two-stage cluster as well. And you may compare the actual groupings between the different methods that you use to feel fairly certain and comfortable that what you have is appropriate, rather than just relying on one method only. And again, the K-means non-hierarchical approach is pretty limited in that it doesn't really allow you to select different methods or distance capabilities. It's all preset for you. So it makes it easy, but it also may be somewhat limiting to you. Okay, so again, good luck with this. Have fun. Please try it. Practice, and just explore the technique.